All right, today we are reviewing 2.2c, which is all the power rule, product rule, quotient rule stuff. We'll throw in some other things as well, and Bell work here today is going to do some of those other things, but we'll get to them. Okay, identify the true statements. When we do a calculus test, any AP exam question, they will never do like pick all of the answers that are true. Okay, instead they will do this 1, 2, and 3 thing. It's the same idea. So if you're doing a calculus test, the answer is either A, B, C, D, or E. It's never going to be like B and C. So this is their way of doing that. We want to decide if that equation right there is continuous, differentiable, and decide is f of c going to be equal to 10 on that interval. Show me with your fingers. What do you think? A, B, C, D, E, what you get? We got some 1s, some 4s, and some 5s seem to be the theme. Let's see which one we think is true. All right, if we are continuous, what needs to be true in order for you to be continuous? The limit from the left and the right and the value. All three of those things, left, right, and center, need to be true. The good news is the left and the center are going to get me the same equation. So all I got to do is find the limit as x approaches 2 from the left and see if that's equal to the limit as x approaches 2 from the right. It's multiple choice. You don't have to get this fancy in terms of writing it out, but it's not a bad practice to get into. You take 2, you plug it in, you get 5. You take 2, you plug it in. 8 minus 3 is 5. Is it continuous? Yeah, left and right are the same, so it's continuous. Part 2 says, is f differentiable? What would make a function not differentiable? A corner or a cusp. Everybody agree with me on that? Or being discontinuous. Like if we would have done part 1 and it would have been discontinuous, then all of these problems would be no. Okay, it has to be continuous in order for that to be true. But in this case, we are continuous. So the only other place it could be bad is if there was a corner. How do I determine if there's a corner or not? Care? The shape of the graphs would be helpful. Okay, but it can also be misleading here because one graph is a parabola, the other one's a line. If you put a parabola and a line together, do you think you're going to get a corner? In theory, probably you think that's going to happen, and that's not necessarily true. You don't want to just think about it. Okay? Instead, we did this, and it's been a minute, but the way we can find it is like continuity. We're going to find the limit as x approaches 2 from the left. We're going to find the limit as x approaches 2 from the right, but instead of looking at the values, we're going to look at the slopes. We're going to find f prime of x. F prime of x. We're going to find the slopes at both of those things. Because if their slopes are equal to each other, it's not going to make a corner. It's going to be a nice smooth transition from one line to the next. All right, and we'll show you what that means here in a second. Max, if you're taking the derivative on the left-hand side, what would my derivative be? 2x. What would your derivative on the right-hand side be? 4. And we're finding the limit at 2. So if I take 2 and plug it in, I get 4 is equal to 4. So is it going to be differentiable at that spot? Yes, because the derivative from the left and the right are equal, they're going to be differentiable. So this is what the graph looks like. You can tell that it's continuous. You can see there's not a corner at that spot. If I zoom out far enough, you can see that it looks kind of wonky because I've got a parabola on one side and a line on the other. But the whole thing is that we don't have a corner point. If I zoom in, does that look like there's a corner point right there? No, it's a pretty smooth transition, okay? Because both slopes are 4, they are going to make a continuous differentiable line. You can find the slope right there. It's weird, but you can do it, okay? So because the slopes are equal on the left and the right-hand side, it is going to be differentiable. Make sense? Last one says from 0 to 4, there is a c such that f of c is equal to 10. What are we describing here if we're saying that we have to be equal to some value on an interval? That is an IVT question. In order for IVT to be true, I have to be continuous. Am I continuous here? Yep, so we passed the first bar. What do we need to know in order to decide, am I going to be equal to 10? Endpoints. Like, am I ever going to be 5 feet tall? Well, I need to know how tall I was at the start and how tall I was at the end. I need endpoints. So I need to find f of 0, because that's my starting value, and I need to find f of 4. That would be my first thing. I take 0, I plug it in. I'm going to plug it into this first equation. That gets me 1. I'm going to take 4. I'm going to plug it into that second equation. 16 minus 3 would be 13. I start at 1. I go to 13, and I have a continuous graph. Am I ever going to be 10? Yeah, I am. Okay, there's no way of going from 1 to 13 without hitting 10 somewhere in between. Kind of makes sense what we're doing there. Continuous, the limits are equal. Differentiable, the limits of the derivative are equal. Yes, ma'am.
Okay, so when you're doing like number 3,
Mm-hmm.
does it matter which equation you plug the endpoints into?
Absolutely. It definitely matters. I was doing f of 0, so which equation am I plugging 0 into? The less than 2, and then I would plug the 4 into the greater than 2. It would matter. Other questions? All right, I think we got a little bit better idea. We're going to do a lot of Bellworks here. Let's try that same idea here on Bellwork 2. See if you can do it then. Same idea, try it again. The limit needs to exist. If I want the limit to exist of this piecewise function, what has to be true? Left and right. Limit as x approaches 3 from the left needs to be equal to limit as x approaches 3 from the right. I'm going to go fast here. But if I plug in, it's x plus 2 and 4x minus 7. If I take 3 and plug it in, I get 5. If I take 3 and plug it in, I get 5. 5 equals 5. The limit exists. If the limit exists here, is it going to be continuous? Yeah, because it would also be the value. And the good news for us is it's x is less than or equal to 3. So what would f of 3 be? Well, it would still be 5. I would just plug it into that. So that one's good as well. Differentiable. In order to be differentiable, what needs to be true? The slopes need to be equal. Okay? What is the derivative of that equation going to get me? What's the derivative of that equation going to get me? Is 1 equal to 4? Nah, so there's going to be a corner point there. So that one's a no. So I want 1 and 2 only. My answer is D. Make sense? We just practiced it twice there. That way it would kind of be in our brain a little bit more than just the first time. Not too bad. Let's try one more here. Just not something we're going to cover specifically today, but a good thing to put back in our mind. This is a graph of f. Which one of these graphs, talk with your neighbor, which is a graph of f prime? Talk with your neighbor, try to figure that one out. What would you say, we're looking for f prime, so f prime is the slope. What would you say is true about the slope this whole period? I disagree because you all said it at the same time. The slope is not increasing. The slope is constant. What is true about f? F is increasing. So what would be true about the slope? The slope is positive. Be careful there. The slope is positive. So when we graph f prime, that's the slope. I need to be positive. So it could be A, it could be B, it could be D, it cannot be C. During this next section, okay, from 2 until 3, what is true about f? F is decreasing. So what needs to be true about f prime? F prime needs to be negative. So right there f prime is negative. Right there f prime is negative. Right there it's not. It's not B. It's either A or D. Then in the next section of my graph, what is true about f? F is increasing. So f prime needs to be positive. F prime needs to be positive. Nope, not on that one. There f prime is positive. The answer is A. Be careful with your language. You're doing well. We understood what it was on. But make sure we say f is increasing. That means f prime is positive. That's something that's kind of silly, but is incredibly important. It seems silly, but it is not. All right, today we are working through this multiple choice review. Okay, I have whiteboards on your desks. I thought we were going to do it as whiteboards. We are not. Okay, instead we're just going to jump around. Okay, we're going to do this worksheet. It's a good worksheet. Okay, but we're going to kind of find which problems we should do together, and we're going to be able to do those together and see how you did. Okay, each time we do a problem, you're going to show me with your fingers what's the correct answer, and we will go from there in terms of what's correct. Okay, let's start off here with number 2. Okay, get an answer, show me the answer, think about what method you need in order to find it. Go. Point. Let's go over. Okay, we're finding the derivative. What rule do we need to find the derivative of this thing? Why do you know that it's quotient rule? The reason is because there's x in top and bottom. Okay, if I look at number 1, a lot of students will make a mistake and say number 1 is a quotient rule problem. It is not. Okay, number 1, you could just rewrite it because 6 is just a constant, and then you could rewrite it as x to the negative 6th. Okay, you can rewrite that one. Number 2, you can't not rewrite in the same way. Okay, for some reason my f disappears here, but there is an f in front of all of those. It just randomly disappears. All right, so we're using quotient rule. So if we're doing that, it is low d high. The d high is going to be 2x minus high D low. All over. Low, low. That is my derivative. And if it were free response, we would leave it that way. It will not be free response. This kind of question would be multiple choice. Notice that the bottom is squared. It is going to stay like that in your answer. This is how it would look on the AP exam as well. They're just going to leave the bottom the same. All we have to do on top is simplify. Okay, so if I distribute there, it's going to be 2x cubed plus 2x. And if I distribute here, I got to distribute both that negative sign in there as well. Negative 2x cubed minus 12x. Those two things are going to cancel. 2x minus 10x is going to get me negative 10x. Questions on 2. Let's go to number 3. Given the table of values, compute the derivative of h of x is equal to that. I just missed this on here, but you are trying to find h prime at 3. That is the ultimate goal. Find h prime at 3. Show me an answer once you get there. We're finding h prime of x. What do I need to take the derivative of that thing right there? Product rule. So it's going to be first times the derivative of the second plus the second times the derivative of the first. One of the biggest mistakes kids make here is they stop at that point, okay? Because you just put in so much effort of doing product rule, you forget about this little guy right here, okay? So it's just that plus the derivative of f of x. What's the derivative of f of x going to get me? That is f prime of x. So that is h prime. We're going to find h prime at 3. So everywhere I have one of these guys, I'm going to plug in the value. So f at 3 is going to get me 2. G prime at 3 is 4, plus G at 3 is 3. F prime at 3 is negative 3, and then plus a negative 3 at the end. That's 8 minus 9 minus 3. It gets me negative 4. Questions there? Let's jump to the hardest one. Flip that paper over to the back side. Let's look at number 7. I strongly suggest you talking with your neighbor, but this is a graph of G prime. It is a G prime graph. Which of the following are true at x equals 2? See what you can do. Let's see what we can do here. It's a tough one, so don't be discouraged if at first glance this one's rough on you. This is a graph of G prime. This is the key to everything that's happening here. It's a graph of G prime. What does G prime tell you about G? This is the slope of G. That's what this is. This is the slope of G. Okay? Most specifically, okay, you probably can get everything right except for that. If I were to ask you what G prime at 2 is, this is a graph of G prime, what would you tell me G prime of 2 is? It's not labeled, but in general it's 3. Sure, let's go with 3. It doesn't matter. We're just going to say that it's 3 for a second. Okay? So, is G continuous? Yes, because if I can tell you what the derivative is, the slope at 2 is 3. If I can tell you that, that means that it has to be continuous because you can't find the slope if it's not continuous. Okay, so G is continuous. Is G differentiable? Yes, because I know what the differentiable means. You can find the slope at 2. I can find the slope at 2. The slope at 2 is 3. Okay, because there is a point right there makes it differentiable. Okay, if there was an open circle, then no. Could you find the derivative of this graph? No, because of that corner point, I can't find the derivative of this graph, but this already is the derivative. All right, so is it differentiable? Yeah, because there's something there. The fact that there's a point there at 2 makes it differentiable. Is G increasing? What is G prime is positive? If G prime is positive, show me with your hand. What does G prime is positive mean? It's going up. It's G is increasing. Means G prime is positive. Okay. This is what does a slope of 3 look like? It looks like that. What's happening? It's going up. The slope is positive. That means G is increasing. All 3 of them are true. We will do this again in unit 3. Okay. So if that we just did that problem and your brain hurts, fine. We're going to do it again. We'll look at a ton of G prime graphs, but that's a good one to kind of get us going. Questions there? Let's go to an easy one after a hard one. Let's look at number 5. See what you can do on number 5. Go. We are finding the derivative. Don't let dy, like someone earlier saw that and they were like, oh, I got to use quotient rule. No, dy over dx just means the derivative. That's all we mean. Okay, we're finding y prime. If we're finding y prime here, you multiply by the exponent. You subtract 1 from your exponent. We get this right here. Okay, we multiply by my exponent. We subtract 1 from my exponent. We get that right there. What's the derivative of negative 2 going to get me? 0. So that's my answer. Okay, on this one, it's easy because it's right there. Now, they could have been mean and given you a lot different answers. We got this, but is that the same as this thing right here? Are those two things the same? Yeah, those are the same. What about letter D? If I would not put that, are those two things the same, E and D? Yeah, they're the same. They could be giving it to you in different ways. There's a lot of things that look good. You just got to be able to figure out which one is the correct one. Questions there? Let's go to the second hardest one on this review. Let's look at number 4. Find the second derivative. You're finding the second derivative. See what you can do here. All right, so as we look at this thing, we're finding the second derivative. So in order to find the second derivative, the first thing I got to do is find the first derivative. All right, if I'm finding the derivative of x times f of x, what rule am I going to need to find that derivative? Product rule. So we're doing product rule. So it's first times the derivative of the second. What's the derivative of f going to get me? F prime. Plus the second times the derivative of the first. Be careful here. What is the derivative of x? 1. The derivative of x is just 1. Okay? Because x is a variable. The derivative of x is 1. Just like the derivative of 3x would be 3. We don't have x prime. Okay? Sometimes students will want to go to x prime. That's not a thing. Okay? There's my first derivative. Right? It's times 1. So if it's times 1, that 1 doesn't even really matter because it's just times 1. But the problem here is I need to find the second derivative. So if I find the second derivative, what am I going to need to take the derivative of that first part there? Product rule again. And so I'm going to have to do first times the derivative of the second, which is f double prime, plus the second times the derivative of the first. The derivative of x is going to get me 1. But don't forget about this guy. What's the derivative of that f of x going to be? F prime. Okay, that's kind of the key here. That's why I'm guessing a lot of you got B. Yep. If you got B, you had the right idea. We get this right here. That's going to get me this. But I've got not only one f prime of x, I've got a second one. That is why it is 2 f prime of x. That's why the answer is E and not B. Questions on something we did today?